Hello, good day to you. Hope you're enjoying this day, and hopefully watching this video makes the day a little bit enjoyable, a little bit more enjoyable, I'll say. We've had some fun with probability, and now that we've done that, I'm going to spend just a couple minutes explaining some of the definitions that go along with probability. Just so when you see certain words, you'll know what those words mean. So hopefully these next few minutes will be enlightening, will make some sense, and here we go. Get me out of the way. Okay, I've got some distractions going on. Yeah, this is a major distraction, actually. Let's get rid of that puppy. All right, here we go. You already know, and we've already talked a little bit about what probability is. If I can quickly write this so that I don't spend too much of your time. The probability of an event occurring is a fraction. And the words you'll see written in math is you put the number of favorable outcomes on top, or the number of ways it can occur, which is however the event can happen. How many ways can an event happen? How many ways can you roll a 6, or can you flip a die, or spin a certain number? How many ways can you do that? That's the numerator, the number on top. Then on the denominator, the bottom is the number of all possible outcomes. When you roll a dice, should have had a dice with me. When you roll a dice, you know there's 6 possible sides, and so you a 6-sided dice. If I did a 20-sided dice, that'd be a lot of fun. We could do a lot of good things with that. Now, this fraction is always written in simplest form, or we sometimes use the word lowest terms. So if I say, oh, the probability of choosing a student out of my class that's wearing blue, and let's say blue, and let's say that in that class there were 36 students and 18 of them had blue on, that is not how we would write the probability. We would just keep reducing it. I can cut that in half. Well, I can divide those by 3. Oh, 3 goes into both of those. I just keep reducing it until I get down to its simplest form, or lowest terms. So there's just a little bit of a review about probability. Why go over that? Well, because now we're going to spend a couple minutes on this thing called sample space. You know what this means, you just don't know that you know what it means. When I roll a dice, you know, that's a 6, and let's say I've got a 2 there, let's say I've got a 3 here. When I roll a dice, what's the sample space? What is the space is all of the samples, all of the items. What is the space in which I could get my answers? What are the possible outcomes when I roll a dice? And so it's written with brackets. I have brackets on there. And then they just list all the items with a comma in between. Well, I could get a 6. There's a 6 there. I could get, what else could I get? A 4. I could get a 1, I could get a 5, I could get a 3. Is there anything else I could get? Yes, well done. I could get a 2. Now, I'm doing that on purpose. That's not how you're going to see it written. The whole purpose of this is to write it as organized as possible. So you get a 1 or a 2 or a 3 or a 4 or a 5 or a 6. That is the sample space on this 6-sided dice. And it's really that simple. If I want to choose a color of the rainbow, so you know here's the rainbow. If I want to choose a color of the rainbow, what's my sample space? Well, there's red, orange, yellow. Let's see, Roy G. Green, blue, indigo, or violet. That is the sample space of colors on the rainbow. What if I want the sample space of, say, a suit in a deck of cards? Deck of cards. What's the sample space there? Well, let's see. What are the suits? There's the hearts. That's a suit. Yep, spades. Spades is another one. Awful spade. Let's go with it. Let's see. Heart, spade, clubs. A club is a possibility. And then finally, a possibility is a diamond. So the sample space just means what are all the possible outcomes. It is this number right here, the number of possible outcomes, all listed out. So the connection here that we're looking at is the sample space. There's 1, 2, 3, 4, 5, 6. The bottom number on this fraction is 6. The number of suits, if I want to pick a suit, well, there's 4. So 4 would be this bottom number there. Why spend time on this? Why show this? Because, and let's see if maybe I can kind of keep this here for a second. This is what makes up what we call a probability model. A model, or means all the information that you need. It's the probability of the event and the sample space. So whatever is the events that they're talking about, they'll usually even list out all of the different events that could occur, and then they'll have a list of the sample space. Sometimes it'll be organized in a list. Let's say enrolling a dice. Well, you could roll a 1, 2, 3, 4, 5, or 6. There's a sample space, and sometimes they'll have the number of times it was rolled. What's the probability of rolling a 6? And then they'll give the items there, or the probability of rolling a 1. Anyway, it's the probability and the sample space, and it's organized in some way. That's a probability model. And that's the main message of today. We'll go ahead and let you know that you can have a uniform probability model or a non-uniform one. A uniform probability model is the ones that we look at. The ones when I mentioned the word fair, it's because there's an equal opportunity of all of them to be chosen. Rolling a dice, there's 6 possibilities. When I flip a coin, I've got this yellow and red counter. When I flip it, there's an equal opportunity out of 2, and so this one there's 50% because it's just split up 2 ways. The 6, there's just 1/6 of the ways to do it. If I did a spinner with 8 sections, let's do a spinner, and if there's 8 of them, if there's 8 options, and there's 12.5% chance for each one of them, or the same thing as 1/8. A deck of cards. If I'm looking at a deck of cards and I'm talking about a suit, there's 4 possibilities. Or if I'm talking about a certain number, well, there's 13 different numbers, so you could use those 13 different numbers. I'm showing you an example right now of a non-uniform. A non-uniform is when there's not the same amount of non-uniform probability. Saved by the bell, you think, but we're not done yet. A non-uniform probability is something like this, where I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's 14 items. So what's the probability of choosing red? We'll see how there's 2 reds, but there's 3 yellows. There's only 1 brown. And look, now there's even no browns. I mean, there's not the same chances. There's not an equal chance of all of them being chosen. And now it's only out of 13, so it's even worse. There's a non-uniform probability. Here's a spinner. And which one, if I said, hey, I'm going to give you $1,000 if your spinner lands on a certain one, which one would you choose? Well, you can see there's not an equal amount of possibilities. The A, has what, twice the possibility of a B or a C being chosen. So this is non-uniform, meaning it's non-equal, it's non-fair. Non-equal, non-fair. Most of life is not uniform. So most of the probabilities that we talk about are not uniform. They're close, and there's some we try to make close, but the difference between uniform and non-uniform. Here's non-uniform right there. There's 13. Let's see if let's see. Oh, here we go. Now there's only 1 blue. I mean, there's only 1 blue. I mean, and now there's 12. I can do some probability with 12, but 3 oranges, 3 greens, 3 yellows, 2 reds, 1 blue. It's not uniform. A counter would be uniform. If, you know, flipping a coin would be uniform. Yeah, I've got some coins here. If I'm flipping a coin, it's going to be a uniform at 50%. Or if I'm choosing a card out of it, let's say I want to choose a red card. Well, to choose a red card, you know that half are red and half are blue. So you know there's a 50-50 chance that I'm going to get red. So right there, did I get red? Well, it's a 50-50 chance. I didn't get it. And just to have fun, if I do it 2 times, you'd think that I'd get 1 red. Let's see how closely life matches probability. So do I get a red? Nope, twice, and both times didn't get a red. But I had a uniform probability, a 50% chance of getting a red. So anyway, just a couple of little thoughts, just a few definitions regarding probability, sample space, probability models, the definition of probability. Really, you're set. Hope this made sense. Hope these 11 minutes has made your life a little better. Talk to you later.